interfacing LED with the 8051 microcontroller. So which kind of the question may be asked in the exam? So write a C language program to turn on and off LED after 20 milliseconds. Here is already mentioned the 20 milliseconds. After the 20 milliseconds, LED will be on or off. The question may be asked to draw the interfacing LED with the microcontroller. So here you can write in this way the interfacing circuit diagrams of LED with the microcontroller. So first of all, these are the two circuitry, this one and this one are very important, and by default whenever you draw the interfacing circuit diagrams with any verified device with the microcontrollers, you must be draw recess circuitry, and this is the crystal circuitry. So recess circuitry pin number 9, and here we have correct the R1. So R1 may be 1.8.8K or it may be 10K. So here whenever you want to reset the microcontroller, then just press the switch and microcontroller will be reset. So what do you mean by the reset? What is the use of this switch? So when we will press this button, then microcontroller may be stop all the activities, and the microcontroller will start the program from the first memory location, that means 00 memory location. Now these are the crystal here, 12 megahertz, and C1 and C2, these are the capacitor, 33 picofarad capacitor. They are recommended by the manufacturer. So here we can consider 12 megahertz crystals to the pin number 18, pin number 19, and pin number we can say that here 20. This is the ground is 20, and this is the VCC for 40. So here we can connect the power supply, and now in the program there is no mention the pin numbers. You can take any one pin numbers of the microcontroller. You can take any port. Pin 1.2 I have used here, and here we have connect the LED to the pin number 1.2 via the 330 ohm resistor. So now let's see how to write the program. The first of all, we have to write here the hash include register 51.8. So this is the by default we have to write here. Now then we have to initialize the pin, that means pin 1.2, and we have required a single pin, that's why we have to use the S bit, and we have used the variable LED, and this is connected to pin number 1.2, and there is a semicolon. So in this way we have used the variable for the pin number 1.2, and now forever in the program we can write here the LED as a variable. So this is the which type of the variable we have used here, the S bit. So now then we have to record the delay, so that's why we have to use the another function, special function, that is the while delay, and unsigned integer and semicolon. Now then you can start the program while main. Actually our programs will be started over here, or you can write here the while inside, because we have to use the different functions over here. Now then semicolon, that means your programs will be start over here. Now LED is equal to 1. What is the meaning of this? Here LED will be on. So how much time? 20 milliseconds. That's why I have used here the 20 milliseconds. Now again LED will be off after 20 milliseconds. Then we have used here the 20. So now here our program is over. So now we have use here the while delay as a subroutine. While delay unsigned integer t, unsigned integer t, curly bracket unsigned integer x and y. For loop, we have used here the for loop for generating the delay. X is equal to 0 semicolon, x is equal to less than t and x plus plus. And then another for loop here, y is equal to 0, y less than 1 to 75 and y plus plus, and bracket completed. Now here while delay loop is 1. So now here while delay unsigned integer t. Unsigned integer t means t, it is our, what is the value of the t? T value is nothing but the 20 milliseconds. So here unsigned integer t, here we have used the t for the 20 milliseconds. So now unsigned integer x and y, these are the two variables we have used for the for loop. So this is the first for loop, x is equal to 0 semicolon, x less than t and x plus plus. So this one x variable will be increased up to the incremented by 1 up to the t. That means t's value is nothing but the 20. Up to the 20, this first for loop is execute 20 times, and the for loop, second for loop, here we have used the variable y is equal to 0 less than y less than 1 to 75 semicolon plus plus. So this one for loop it is incremented or up to the 1 to 75, and this one 20. So overall we can say that these are the for loop, they may be multiplied to each other, and we will get the here 2000 milliseconds. That means we will get here the 2000 seconds. That means we will get here the 20 milliseconds delay. So in this way, so this program is over, and this while loop subrouting program, it is the same for all the program.